All right, good. So we're going to finish up this describing data chapter today. And then we're going to talk a little bit about the schedule up to exam 1, because we are roughly a week ahead of schedule, or even more. So I don't know if that's good or bad. Depends on how you look at it. Okay, so we talked about means as a measure of standard deviation. And we are not standard deviation, a measure of centrality or central tendency. Another method we use, another thing that we use to, measures or central tendency is called a median. Now, we also notice with the mean that if we had an outlier, it would affect the median quite a bit if it was way out beyond the rest of the data. Whereas with the median, that's not so much the case. So the median of a set of data is the value in the middle when the data is in order. So to find the median, we begin by listing the data in order from smallest to largest or largest to smallest. I highly recommend getting into the habit of going smallest to largest. If the number of data values n is odd, then the median is in the middle data value and can be found by rounding n divided by 2 up to the next whole number. So even, well, it'll always be. So if you have a decimal value when you divide, you're going to round up. If the number of data values is even, there is no middle value. So we find the mean of the two middle values, which would be the values at the position of n divided by 2 and the position of n divided by 2 plus 1. Two values next to each other. So let's do a couple examples of this and see how it works. So we're going back to our football touchdown data, and if you recall, n was equal to 31. We want to find the median. So to find the median, we just take n divided by 2. 31 divided by 2, 15.5. So we round up to 16. And what 16 is? 16 is not the median. Well, it might be, but it's not. 16 is the location of the median in the list of data. So we're looking for the 16th data point. So we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our median equal to 20. And if you look after the median, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points as well. So it split it right in half. 15 to the left of it, 15 to the right of it. So here we have a set of data. Find the median of these QUID scores. So first, we need to put it in order. And as I said, I like to use ascending, and you'll see why by the end of the chapter. Now there's a 2. There's a 4. I see 2 5s. I see 1 6. I see 2 7s. And I see 2 8s. And I see a 10. And I believe that's 10 data points. So now n equals 10. So to find the median, we take n and divide it by 2. Oops. N divided by 2, which is 10 divided by 2, which is 5. So since we get a whole number, we take the 5th plus the 6th, and we want the mean, so we divide by 2. So I got a 6 and I have a 7. So 5 or 6 plus 7 divided by 2, 13 divided by 2, 6.5. So our median is right here. And if you notice, there's 5 data values to the left of it and 5 data values to the right of it. The median splits it in half. Any questions on medians so far? Okay, so now we have our frequency list here. We have 100 data values, so n equals 100. Actually, let me write this over here. So, since n is an even number, we need to find the mean of the 2 middle data values, the 50th and 51st. And 100 divided by 2 is 50. I need the 50th and the 51st value. Everybody with me there? Not just because it says it, but because we just calculated it. Now, here's where this can get tricky. So the first 6 data points are at 15,000. So right now I have 6 data points. The next 8 are at 20,000. So now my first 14 are from here down. Then my first 25. Then my first 42. Then my first 61. Does everybody follow what I did there? So this 35,000 income has data point 43 through data point 61. That makes sense? I mean, otherwise we'd have to write out all 100 of them. I don't think we want to do that. So where is the 50th and 51st data point? What value do they have? 35. They're both in that range. So to do the calculation, we would take 35 plus 35 divided by 2, 70 divided by 2, which of course is 35, and that would be our median. Any questions on the median using a frequency table? Everybody good? A couple people still writing. Ready? So now we come to one of the easy ones. The mode is the element of a data set that occurs most frequently. So looking at our color data, what's the mode? Which color has the highest frequency? Green, I think. 5. So in this case, our mode would be green. Okay. It's possible for a data set to have more than one mode if several categories have the same frequency, or no modes if each category occurs only once. So what's the mode of this data set? Is there any value that occurs more than the rest? I don't think so. So there is no mode. Okay. And should you come across the test question with no mode, It asks for a mode. Please point out that there is no mode. That brings us to our next. The range is the difference between the maximum value and the minimum value. So we have some quiz scores here listed, and they've been nice, and they listed them from smallest to largest for us. What's the range? Well, we take the maximum value of 98, we subtract the minimum value of 71, 27. This is one way to tell us how spread out the data is. Any questions on range? I think we have another one, yeah. So we'll go back to our 8 employees. What's our range here? Well, you take the maximum amount, subtract the minimum amount, and what we get? 20,300. That's the range of salaries for those 8 employees. Any questions on this? So we covered median, mode, and range. Next up is the biggie. Any of you have to take statistics eventually? This is something you'll revisit in statistics. Called the standard deviation. It's a measure of variation based on measuring how far each data value deviates or is different from the mean. Some characteristics. Standard deviation is always positive. And it'll be 0 if all the data values are equal, and it'll get larger as the data spreads out. So the larger the range, the larger the standard deviation. Standard deviation has the same units as the original data. So if our data was in seconds, our standard deviation will be in seconds. And standard deviation, like the mean, can be highly influenced by outliers. So we have to be careful of that. So how do we do this? First, we find the deviation of each data point from the mean. In other words, subtract the mean from the data value. Square each deviation. Add the squared deviations. Divide by n, the number of data values. The data represents a whole population. Divide by n minus 1 if the data is from a sample. We'll be doing samples. The formula on your exam will be for samples. And then compute the square root of the result. So here is the formula you will see with your exam. S, standard deviation, is equal to the square root the sum of x minus x bar squared over n minus 1. We have to do this for each data point in the data set. So that's represented by the x. The x bar is the mean. And then, of course, n is the number of data points. So you don't have to do it the way I'm about to show you, but I highly recommend it because it makes it easier to keep track of everything. So I usually develop a table. I start out with my list of x's. 7, 9, 11, 15, 18, and 12. Now I need the median. I need the mean, and n equals 6. So if I add all these together, I get 72. So we're calling this a sample. So x bar is the sum of x's over n, which is 72 over n, which is 12. So the next thing I want to do is see how far away from the mean each data point is. I'm going to take x minus the mean. 7 minus 12 9 minus 12, 11 minus 12, 15 minus 12, 18 minus 12, and 12 minus 12. We'll go ahead and we'll calculate these. -5, -3, -1, 3, 6, and 0. But what I need is x minus x bar squared. So my next column, x minus x bar squared. So I take these results here and just square them. -5 squared is 25. -3 squared is 9. -1 squared is 1. 3 squared is 9. 6 squared is 36. And 0 squared is 0. And then I need the sum of them. So I add them up. Well, yeah, 34, 35, 44, 50, 80. So that is my sum. That is the top part of this fraction here. So S, the standard deviation, equals the square root of the sum of x minus x bar squared, which we calculated as 80, over n, which is 6 minus 1, so over 5. So 80 over 5 is 16, so this is 4. And like I said, it's easy to keep track of it if you do this table. You don't have to, but I do highly recommend it. Any questions on how to do that? Now, there is a homework question with standard deviation, so you can pretty much be guaranteed there will be a test question with standard deviation. Okay? You see a couple of people still writing. Sure, you added 0. It's the 6th data point. But since we're using a sample, we calculated it by n minus 1 instead of n. If it were a population, we'd use n. And for the most part, I calculate it both ways in case you forget. But on the exam, this will be the equation you're given. You'll see a couple people writing. Everybody got it? Okay, next up is something called quartiles. Quartiles are values that divide the data in quarters. First quartile, Q1, is the value so that 25% of the data values are below it. The third quartile, Q3, is the value so that 75% of the data values are below it. And of course, the second quartile is the median. 50% of the data values are below it. This divides the data into quarters. So that brings us to our next thing called the 5-number summary. The 5-number summary is basically the minimum of the data list, Q1, the median, Q3, and the maximum. So how do we find these? To find the first quartile, you're going to want to order the data from smallest to largest. See, I told you, smallest to largest is the way to go. Then compute the locator. L equals 0.25 times n, where n is the number of data points. If L is a decimal value, you round up, no matter what decimal value it is. If it's 2.000001, you still round up. It won't be, but if it is, round up anyway. It kind of, I guess we can call it bump it up instead. That way you won't get confused with traditional rounding and what this is. Anytime when you're calculating a location, if you get a decimal in your answer, you bump it up to the next highest whole number. If L is a whole number, you need to find the mean of the data values in the Lth position and the L plus first position. And to find the third quartile, it's the same way as the first, but the factor is 0.75 n. So let's look at this. Suppose we measured 9 females and their heights in inches sorted from smallest to largest are. Find the first quartile and the third quartile. So we have n equals 9. Find the location of the first quartile. We take n, or 0.25 times n, which is 0.25 times 9, which is 2.25. So we bump it up and we want the third data point. So Q1, 1, 2, 3, is 62. Okay. Then to find the location of Q3, 0.75 times n, 0.75 times 9, which is 6.75. So we're going to bump it up to the 7th data point, 4, 5, 6, 7. So Q3 equals 69. And while we're here, why don't we practice finding the median? So for the median, we say n over 2, 9 over 2, which is 4.5. So we bump it up to the 5th data point, which is 66. And just for fun, what's the minimum? What's the lowest data point? $59. And what's my maximum? 72. I'm cheating. There's a question later that asks for the 5-point summary of this data. So that is it. Any questions on how we did that? A couple people still writing. Yes. I'm sorry? This is telling me that Q1 is the third data point. 1, 2, 3. And then Q3 is the 7th data point. Okay. Good question. Because I don't know how many times I get for the answer for this, a question like this. It's 3. It's not 3. That's the location. Are we ready? Anybody need more time on this? All right, next one. Now we have 8 females. So n equals 8. And I think we'll go ahead and go through the same process. So let's go ahead and put it all over here. Min, Q1, median, Q3, maximum. So we can find the minimum and maximum real quick, right? What's the minimum? 59. What's the maximum? Okay, Q1. So we want the location of the first one of Q1. we take 0.25 times n to 0.25 times 8, which is 2. So when we get a whole number, we take the second, in this case, plus the third, divide it by 2. So the second number here is 60. The third number is 62. Divide that by 2, and we get 61, which would be right here. Okay. Now to find Q3, the location of Q3 is 0.75 times n, 0.75 times 8, which is 6. So now I need the 6th plus the 7th over 2. 3, 4, 5, 6, 67 and 69. 67 plus 69 over 2, which should give me 68, which would be right here. Okay. And now we'll go ahead and find the median. Finding the median, we just take n and divide it by 2. 8 divided by 2 is 4. So again, we take the 4th plus the 5th divided by 2, which is 64 plus 66 divided by 2, 65, which would be right here. See what I did? I showed how it splits it into 4 even sections. 2 data points each. And it'll ask for this later, so there it is. Any questions? Any questions about the 5-number summary? Traditionally, we list them in that order. And so if I remember, yep. See, page 25. And see page 26. Because we already did. They wanted the 5-number summaries. Okay. So next up, the last thing on this chapter. A box plot is a graphical representation of a 5-number summary. To create a box plot, a number line is first drawn. A box is drawn from the first quartile to the third quartile, and a line is drawn through the box at the median. Whiskers are then extended out to the minimum and maximum values. So here is the box plot for the 9 female height data. Now we want to create one for the 8 female height data. So I need your help. What was Q1 for the 8 female height problem? The last one we did. Q1. Okay, 59. $61, right? Q1, Q3. Thank you. So Q1 is 61, Q3 is 68. We build a box. What was the median? 65. So we draw a line there. What was the minimum? 59. So we draw a whisker. What was the maximum? 70. So we draw a whisker. There we go. Box plot. I don't think there's a test question on that anymore. But it's just another way to look at the 5-number summary, which is on the test. And like I said, if you end up going into statistics, memory serves me correct, psychology majors, maybe sociology majors or social workers. I think they have to do statistics. I'm not sure. I know psychology does. Everybody good on this? Now we're going to a fast food restaurant, or one of two. We have a box plot of the service times for two fast food restaurants as shown below. Okay. So, while store two has a slightly shorter median service time, 2.1 to 2.3, store two is less consistent with a wider spread of the data. At store one, 79% of the customer, or 75% of the customers, see, this is Q3, are done within 2.9 minutes. While at store two, 75% of the customers were served within 5.7 minutes. Which store should you go to in a hurry? I'm sorry? Store one. You have a 75% chance of getting out of there in less than 3 minutes. Any questions on this? Hey, this wasn't too hard, was it? So this next part, those of you online, doesn't mess with your schedule because you're online and you'll be taking the test online. This is only for students that will be in the in-class portion or section of the course. What has happened is we have 2.5 weeks to get through one chapter. And that's it. Yeah, it is a dense chapter, but it's not that dense. So here is my plan. So Thursday and next week, we'll do the probability chapter. Should be able to go 3 days with reasonable time. We'll still get out early. And I doubt we'll take the whole class time during this. Then on the 19th, we'll look in depth at the project. I'm going to go into more detail on it than I normally do. We're going to do some things with it that I don't normally have you do, but I think that it will help you appreciate the experience more. And then on the 21st, we'll do the test review. So coming back on the 26th or the 28th. Exam number 1. So what this means is you could come in Tuesday the 26th, take the exam, and then take the 28th off. Or you can take the 26th off and come in the 28th. But if you do that, you better not be sick on the 28th. Yeah. So logic would dictate that I see the majority of you on the 26th, but I know better from past experience. So what I'm saying is you could come either day. You don't have to come both.
Does that change the schedule for like homework turn-in?
Homework turn-in will be the same. Because the original test date was the 28th. So essentially, every class up until exam 1 is going to be probably between 45 minutes to an hour at most. I hope you don't mind getting out early. I mean, I got to be here, so if you want to hang out, I'm sure I could come up with something for us to do.